So everybody turn back to problem number 16. Oh, of course. Oh, not that one. Okay. All right. What is the main operation going on here? Division. Yes, we have one expression divided by another. So what I'm going to do is separate these kind of into groups. I've got my coefficients out front, I've got some H's, I've got some J's, and I've got some K's, okay? So like I said, I'm going to divide them up. First I'm just going to rewrite some of this. So I've got 36 divided by 6. I'm going to just keep h to the 0 divided by h to the negative 3, j to the 8th divided by j to the 7th, and k to the negative 1st divided by k to the negative 5th. And I can tell that's a little too wide. All right. So do you see how I have these lined up? Okay. So 36 divided by 6, what is that answer? 6, right? If you're not sure, you can use your calculator, and that gives you 6. And for right now, I'm going to put it as 6 over 1 because there might be something in the denominator. Okay? H to the 0 divided by h to the negative 3. So this is division where I have the same base. What do I do with the exponents? Subtract. So this is going to become h to the 0 minus negative 3. Now, when you subtract a negative 3, you need to change that to adding the opposite. So now it's really going to be h to the 3rd, right? Okay. So j to the 8th divided by j to the 7th. I am dividing. What do I do with those exponents? Subtract. And what is 8 minus 7? 1. So that gives me j to the 1st. This is my little subtraction here. And then we have the k's. K to the negative 1st divided by k to the negative 5th. Again, I'm going to subtract. I'm going to write this one out though. K to the negative 1 minus negative 5. You cannot have that double negative, so you change that to adding the opposite. So I'm going to simplify a little bit here. I have 6 over 1. H to the 0 plus 3 is h to the 3rd. I'll get you in a minute. J to the 1st. And what is negative 1 plus 5? 4. So that is k to the 4th. Oh, so I guess I don't need anything on the bottom. So final answer would be 6 h to the 3rd, j, k to the 4th. Did you have that, or did you not even go there? No? Anybody happen to get that answer? Do you see how I got it? Does it make sense? Did you have a question, Nehemiah? You can. See, and this is the beauty of math. This is the angst of math. Excellent question. She said, in case you didn't hear her, k to the negative 1st divided by k to the negative 5. You can either subtract, or since you know it is a negative, you could switch both of them, right? Because they're both negatives. So if you switch this to the bottom and switch this one to the top, you end up with k to the 5th divided by k to the 1st, right? And then when you subtract, guess what? You're still going to get k to the 4th. So whether you do it by subtracting or whether you do it by moving the negative to the opposite part, you will still get the same answer. Excellent, excellent question. Does that make sense to you? Okay. All right. Other questions that you either have problems with or you're looking at it now and you're like, I don't know how to do this. Bear, do you have any questions? You have any questions? Any questions? Ask. Guys, come on. This is where just fire away with the questions. Lens, do you have any questions? Well, geez, let me see. Ooh, say it again. 20. Oh, yes, I definitely want to go over this. Number 20. So this is a cube. It is a three-dimensional figure. Has sides that are all the same length. That's key. Sides that are all the same length. The volume of a cube is V is equal to one side to the third power. So side times side times side. Okay, that's what it means. Side times side times side. If the length of one side of the cube is 3m to the sixth n to the fifth, so here's one length of your side, and we're saying this is 3m to the sixth n to the fifth. I don't think I said that right before. What is the volume of the cube? Well, if this is the length of the side, what would I substitute that in for? The side, S, right? So I am substituting S, or I'm substituting this in for S, and that is 3m to the sixth, n to the fifth, and then that whole thing, if I want the volume, I have to raise to the third power. Now this becomes a problem of exponents. This is my 3 on the outside. When I have that whole expression raised to the power, what do I do with the exponents? Multiply. This is like the spider. And you multiply. There's no exponent on the 3, so put a 1 on it. So that's 3 to the 1 times 3 times m to the 6 times 3 times n to the 5 times 3 gives me 3 to the third, m to the 18th. Ooh, that's kind of a high exponent. Is that okay? Yeah, I mean, it is what it is, right? N to the 15th. And is that my final answer? No, because we can simplify 3 to the third, which on your calculators is 3 caret 3. It's not 3 times 3, it's 3 caret 3. 3 to the third is 27, m to the 18th, n to the 15th, and this would be units cubed, which I'm not so concerned about that, but if you want to be precise, that's what it is, because you're talking about volume. Excellent. I'm so glad you brought that up, Esme. Any other questions? Yes. 19? 19. Rewrite the cube root of 19 in exponential form. So this right now is in radical form. Why? Because it has the radical sign. 19 is your base. Okay? 19 is your base. So you write 19 like this. Whatever power 19 is raised to, that becomes your numerator. And whatever is in the crook over here, let me do a different color. The crook over here, that becomes your denominator. So 19 to the 1/3 is the cube root of 19 to the first power. This is your final answer. Questions on that? And let me check something to see if that is in part of the roots. Yes, take a look back on the very first page. It says a to the 1 over n power. Notice you have the n here. Okay. Your base a is rewritten under the radical. And then you have your numerator, whatever that numerator is. It could be a different numerator. That goes right there. So that is one of the rules that you can refer back to. All right. Other questions? Esme, did you have one? Or Nehemiah? I thought somebody started to say something. 19? 13. Like we just did 19. 13. And I do want to come back to 17. 13. So here we are adding a bunch of radicals. What do I have to be able to add radicals together? Same radicand, right? They have to have the same radicand, which is the part at the back of the radical. So I can combine these because they have the same radical of 3. I can combine these because they have the same radical of the square root of 7. Take a look up here. Keep looking up here. So I am going to combine them as like terms. The only thing you need to do is check and make sure you have the appropriate signs in front. So 13 times the square root of 3 minus 9 times the square root of 3 plus, because I have a positive in front of 6 radical 7 plus 5 radical 7. Now, the radicands, you keep those. You don't rewrite, well, you rewrite it once. And then you look at 13 minus 9 is 4. And at the back side, you keep the radical 7s by only writing it once. And 6 plus 5 gives you 11. Can I combine these two terms to be 1? No, because they don't have the same radicand. So this is your final answer. 4 radical 3 plus 11 times the square root of 7. Or 4 times the square root of 3 plus 11 times the square root of 7. Okay? Can we go to 17 really quickly before I forget? I think 17... and probably the last question, because we're not as familiar with that, are maybe some of the most difficult. Number 17 says, which of the following are equivalent? Equivalent to m to the negative 8th times m to the negative 2nd. Select all. You're going to have more than one answer here. Okay? So problem number 17 on the last page. M to the negative 8th times m to the negative 2nd. What does this simplify into? If I put this over 1, what would be the first thing you would do? I can't hear you. I'm old. I'm deaf. Put the negative exponents on the bottom. Okay? Definitely can do that. Yes. So this is now going down here. This is now going down here. So I am going to have 1 over, and remember, when you move it to the opposite part of the fraction, what happens with the negative sign? It's removed, right? So this becomes m to the 8th times m to the 2nd. Do I have that expression somewhere as one of my choices? E, yes. And you're like, well, but that's not exact. Well, it's kind of the same. M to the 8th times m to the 2nd is the same as m to the 2nd times m to the 8th. So E works. Do I have any others that would work here? A. Yes. Wait, let me think. Yes. because if I have m to the 8th over, or 1 over m to the 8th times m to the 2nd, I have the same base. What do I do with those exponents? You add them. So that becomes 1 over m to the 10th, right? Okay, so that gives me a, what else, if anything? Is there any more? D. Yeah, if it's 1 over m to the 10th, is that the same as m to the negative 10th? Well, this would be like over 1, right? And I would circle this and say it needs to move to the bottom, which would be 1 over m to the 10th. And that's what this was. So yeah, that's going to be the same. Anything else? See? Well, D's up here. Here's C. What does this simplify to? 1 over, if I add these together, what do you get? M to the 10th. Isn't that equivalent? Yeah, even though m to the 7th, even though it's not the same numbers at all, it is going to be equivalent. So that one is included too. So you had 4 different answers. But guess how many points this is worth? 3. This will be worth 3 points on the test. So just because it's worth 3 points does not mean there are 3 answers. You have to look at each one individually and say, does this work? F does not work because there they are multiplying the 2 and 8. And the 2 in front, that doesn't have anything to do with it. Okay? So look for one to be very similar to problem 17 here. Okay? All right. How about, let's do 18 so we can get this back page all finished for you. How would I write that in radical form? 53 to the 1/2 power. Monty, do you have any idea? Number 18? I know I need to include a radical, right? It says I need to put it in radical form, so I've got to have a radical. What's my base here? 53. Where's that going to go? In the radical. Okay. What would go on the outside? The 2 would go here in the crook. And the 1 next to the 53. Technically, you really don't need the 1 or the 2, but if you want to be on the safe side, include it. Because anything to the first, anything raised to the 1/2 power is a square root. So you could also write it like this, without the 1 or 2. But if, like I said, if you want to be on the safe side, write them both. So hey, you got the backside done. What other questions? Allie, any questions? You sure? Cake method. You want to see a cake method again? We got, 12, 14, 15. What about 6? Yes. Yes, 6. An expression is said to be in simplest form if these 4 conditions are true. Do you have any idea? Some of they are in your notes, okay? What what do we have to simplify? If something is left at the end and we're like, oh, I can't leave it like that, what do you have to simplify? Fractions. Say more about that. What do you mean? Where? Ooh, jeez. Okay. Yes. I like that. So that is going to be, she's talking about fractions. We need to make sure that every base appears only once. And let me tell you what that means. So what she was talking about, something in fraction form, if you have like a to the 16th divided by a to the 8th, you can't leave it like that. You only have to have a to the 8th here. Okay? You can't leave it like that in fraction form, a to the 16th. So you can only have one base for each number, one base for each variable. Okay? Anything else? Can I have any negative exponents? Yeah. Let me write you a pass. No. So no negative exponents. They all have to be positive. Only positive exponents. Okay? So you can't have m to the negative third. You would have to write that as 1 over m to the third. What else? Kind of goes with what Allie first said. All fractions have to be in simplest form. All fractions in simplest form. Okay, test tomorrow. You really need to do well, okay? No pressure, but pressure. Yeah. What time is it? It's 7:54. And everything is due tomorrow. Okay? So all fractions have to be in simplest form. Simplest form, meaning you cannot leave something like 2 over 6. You would have to switch that to 1/3. Okay, and the last one, you need to simplify all powers to a power. Meaning you can't leave it like m to the second raised to the third. You can't leave it like that. You would need to change it to m to the 6th. Okay. What about number 10? What's anything to the 0 power if you have some big expression to the 0 power? 1. Yes, so you don't even, whoops, I meant to erase that. You don't even have to do a whole bunch of work there. It is actually 1. I think that's on the very front too, isn't it? Let's see. Yes, anything to the 0 power is 1. So again, don't forget those rules are going to be written there. Oh, what about number 5? You know how to do scientific? Yeah. Which one? 12. Yes. 12. Next page. Cake method. Square root. Okay, so I'm going to put 42 and use the cake method. 42 is even, divide by 2 is 21. 21 is not even. You can only divide by prime numbers, so 3, which gives 7, and you're like, wait, these are not any the same. So yeah, 42 is going to be there at the end, if that's what you're wondering. D to the 4, that's even. Divide by 2 is d squared times d squared. D squared times d squared. E to the 5th is e to the 1st times e to the 4th. E to the 4th is even. Divide by 2, e squared times e squared. So that's e to the 1st, e to the 2nd, e to the 2nd. There are no pairs there. Okay? So these come out front because they will give you a square root. And you have d to the 2nd, e to the 2nd, times the square root 42. That is crazy, but there's nothing that's going to come out there, times e. And that is your final answer. Good question at the end. All right. Don't forget, there will be scientific notation. $1,700,000,000. How would I write that as a scientific notation? 1.7. Remember, the decimal has to go between the first two non-zero numbers. You are putting the decimal here. We're moving it to the right. That means it's going to be a positive. And that is what? Times 10 to the 9th? Yes? All right. There it is. Guys, I cannot tell you. Tomorrow's test, very important. Also, homework 1, 2, and 3 all have to be due tomorrow. And the review. Okay? And the review. I am not going to take that just for the problem for today. Good question. I saw everybody was pretty much working on it, so that gives everybody 2 points for today. Also, don't forget, PSAT. I think most of you, if not all, are sophomores and juniors. You need to come with your computer charged and ready to go. Your school given computer. Don't bring a personal iPad. That will not work. Okay? All right.